Example 6, it says the seismic energy X in joules can be estimated based on the magnitude M of an earthquake by the formula X equals 10 to the 1.5 M plus 12 power. What is the magnitude of an earthquake with a seismic energy of 4.2 times 10 to the 20th joules? So, first thing I want to bring to your attention is this is a word problem. They've given us an equation in the word problem right here, and they've told us in words the seismic energy X in joules based on the magnitude M of an earthquake. So when it says what is the magnitude, when it's asking you this question, what are they asking us to find? M. And when it says with a seismic energy of 4.2 times 10 to the 20 joules, what are they telling us? Telling us X, right? Here's X, here's an equation with X and M in it, find M. So basically the extent of this problem is the X value they gave me, 4.2 times 10 to the 20th joules, should equal 10 to the 1.5 M plus 12 power. Now, the way it's written, notice the 1.5 M plus 12, all that is the power, so make sure as you write on your paper that it looks like a power. Don't get lazy and start letting it drift down here to make it look like it says plus 12 after that. So this whole thing here is the power. And notice the structure is what we looked at last week. The right-hand side is 10 raised to some power equals some number. Okay, and what we saw last week was when that occurred, we're going to log both sides with a base 10 logarithm because that's a base 10 exponential expression. So we're going to log both sides, so it's going to be log base 10 of 4.2 times 10 to the 20th power equals log base 10 of 10 to the 1.5 M plus 12 power. We choose the base 10 logarithm purposely because when the base of the logarithm matches the base of the power expression, the end result is simply the power. So the right-hand side here, a base 10 log of 10 to a power is simply going to be that power, like so. And over here, the base 10 log of this number can be evaluated with a calculator. So I grab my calculator, and I'm going to type in this number. Now, different calculators have different ways of entering scientific notation. Most of them have an EE button. Right above the comma there, you see it says EE. These handheld calculators may have an EXP button, I believe it is. EXP, where's that? Everybody seeing it? Oh, here it is, times 10 to the n. It's right next to the pi button. So if your second key come down to the pi, 1 over says times 10 to the n. That's the button you're going to press. So I'm going to type in LOG. For your calculator, you're going to punch second PRB and then choose LOG. And then I'm going to type in 4.2 times 10 to the 20th power. Okay. For your calculators, let's see if I can get this thing turned on. Trying to do something over here. There we go. All right, so I'm going to hit the second key and press this button here, PRB, to bring up the log menu. I choose log. It was 4.2, so I punch in 4.2. Then the button I'm going to press is right here, this times 10 to the n. I'm not going to press the times button. I'm just going to press that button all by itself, like so. And you'll notice it's times 10 and it wants a power and we want 20th power. And we put it in parentheses. Oops. Push the right, hit M parentheses there and hit enter. 20.62324929.
How can you put the 20 on the outside of the parentheses? That's the problem.
What can I what?
The
because I'm taking the log of 4.2 times 10 to the 20th power, not 4.2 times 10 to the 20th. So only 10 is being raised to the 20th power.
But then you write that down. Oh, I
See,
did.
like that?
Sorry.
Okay. So, and just to speed things up, same thing here, 20.62324929. That is what it is. So 20.62324929. 62324929. All right, and I'm just going to as many decimal places as I can for more accuracy. So I just went all the way out there. Okay, this is some number, and it's an unpleasant number. It's got 10 digits, it's got 8 decimal places in it, but it's just some number equals 1.5 m plus 12. This is basic algebra problem. If I'm looking at this right-hand side here, I don't even care what this side says. If I got 1.5 m plus 12, what do I have to do first? Move the 12 over, subtract 12 from both sides first. So I'm going to chop the plus 12, put minus 12. I am dealing with decimals, and the rule of decimals is decimal points line up. 20 is bigger than 12, so that's the bigger number. So I'm going to subtract straight down. I've got 12 followed by a bunch of zeros, so nothing's going to happen in the decimals. There's 62324929. And then 20 minus 12 makes 8. So once I get rid of the 12, what do I do next? Divide by 1.5. So divide by 1.5, divide by 1.5. Again, it's not a pleasant number we're dealing with over here, but our calculator is going to do most of the calculations for us. So I've got to do that minus 12. So there's that. Divide by 1.5 equals, and the magnitude is 5.7. Have you guys heard about earthquakes in the news?
Yeah.
They always go one decimal place on magnitudes, right? There was an 8.7 magnitude earthquake. They don't ever say there was an 8.793456 earthquake, right? So whenever we're talking about magnitudes of earthquakes, one decimal place is pretty common. So you can see I took the 5.74 and rounded it to 5.7, one decimal place, to make it a proper magnitude measure.